name is Widnyana. You can call me Komang. In this video, we will talk about mathematical logic. Especially, we will talk about proportional. What is logic? Logic is the basis of all mathematical reasoning and of all automated reasoning. The rules of logic specify the meaning of mathematical statement. This rule helps us understand and reason with statements such as x is x such that x is not equal to a to the power of 2 plus b to the power of 2, where x, a, and b elements of z, which is in simple English means there exists an integer that is not the sum of two squares. Importance of math logic. The rules of logic give precise meaning to mathematical statements. These rules are used to distinguish between valid and invalid mathematical arguments. Apart from its importance in understanding mathematical reasoning, logic has numerous applications in computer science, digital circuits, and computer programs. Proposition logic. What is a proposition? A proposition is the basis, building block of logic. It is defined as a declarative sentence that is either true or false, but not both. The truth value of a proposition is true, denoted as T, if it is a true statement, and false, denoted as F, if it is a false statement. Example: 1 plus 4 equal to 5. The sun rises in east and sets in west. It's a sample example of proposition, but not every sentence is a proposition. Like x plus y equal to 6. What is your name is not proposition. Next, we will talk about proportional variables, proportional logic, and compound proportional. First, proportional variables. To represent proportion, proportional variables are used. By convention, these variables are represented by small alphabets such as P, Q, R, S. 2. Proportional logic. Proportional logic is the area of logic which deals with proportions. Next, compound proportion. It also includes producing new proportion using existing one. Proportion construct using one or more proportion are called compound proportion. Next, we will talk about truth table. Since we need to know the truth of a proposition in all possible scenarios, we consider all the possible combinations of the proposition which are joined together by logical connectivities to form the given compound proposition. This compilation of all possible scenarios in a tabular format is called truth table. The first common logical connectivities is the first negation. If P is a proposition, then the negation of proposition is denoted by this. which when translated means not P or it is not cases that P. If a proposition is true, so not P is false. If proposition is false, so the not P is true. Next, conjunction. For any proposition P and Q, their conjunction is denoted by this, or P and Q. The conjunction P and Q is true if both proposition is true and otherwise is false. Like if a proposition P and proposition Q true, so the proposition of or conjunction P and Q is true. If a proposition P is true and proposition Q is false, so the conjunction P and Q is false. Next, disjunction. For any two propositions P and Q, their disjunction is denoted by P or Q. The disjunction P or Q is true if one of both propositions is true and otherwise is false. Like if P and Q is true, so P or Q is true. If P true and Q false, so P or Q is true. If P and or Q, if P is false and Q is true, so the disjunction of P and Q is true. And if P is false and Q is false, so disjunction P and or Q is false. Next, we will talk about exclusive OR. For any two propositions P and Q, their exclusive OR is denoted by this. OR is means either P or Q but not both. The exclusive OR is true if either proposition is true and false if both proposition is true or false. Example, if P is true and Q is true, so the exclusive OR P and Q is false. If P is true and Q is false, so the either P or Q but not both is true. If P is false and Q is true, so either P or Q but not both is true. If P is false and Q is false, so the either P or Q but not both is false. Next, implication. For any two propositions P and Q, their implication is denoted by this, or means if P then Q. The implication if P then Q is false if P is true and Q is false and otherwise is true. Example, in truth table, if P is true and Q is true, so if P then Q is true. If P is true and Q is false. So if P then Q is false. If P is false and Q is true, so if P then Q is true. If P is false, then Q is false. So if P then Q is true. Next, be conditional. For any two propositions P and Q, their big conditional is denoted by this. Or P if and only if Q. The big conditional P if and only if Q is true, if P and Q is true, or P and Q is false, and otherwise is false. Example in a truth table, like if P is true and Q is true, so P if and only if Q is true. If P is true and Q is false, so P if and only if Q is false. Next, if P is false and Q is true, so P if and only if Q is false. And the last one is if P is false and Q is false, so P if and only if Q is true. Next, we will talk about solved answer. 1. If P is a proposition with true value is true and Q is a proposition with truth value is false, determine the truth value of A. If Q then P or not Q, exclusive or not P. Q and negation P, not Q or P. The solution. Next, we'll talk about solution. A. P is a proposition with truth value is true and Q is a proposition with truth value is false. The truth value of not Q is true. So, the truth value of P or not Q is true. Then, if Q, then P or not Q have truth value is true. And the last, the truth value of if Q, then P or not Q, exclusive or not P is false. So, the truth value is false. Next, B. P is a proposition with truth value is true and Q is a proposition with truth value is false. The truth value of not P is false, so the truth value of Q and not P is false. Then Q and not P, if and only if not Q have truth value is false. And at last, the truth value of Q and not P, if and only if not Q or P is true. So the truth value is true. Okay, just that I can explain about mathematical logic, especially in proposition. I hope this video can explain about proposition. I hope you enjoy, and thank you for watching this video. Goodbye.